Today we're going to be talking about translations of parent graphs. Our objective is that we'll be able to graph parent functions and translate them using H and K. So what that means is we've also learned a little bit about A. We're not going to be using that today. That's going to be our next lesson. So when transforming parent graphs with H and K, it's going to look something like this. Y equals then X minus H plus K. What these stars are representing are the different functions that we learned about for the parent function. So that symbol is going to be around the X minus H part. So like if we look at our first example, Y equals the cube root of X plus 1 minus 2. Right here is the X minus H part, and the stars were replaced by the cube root symbol. So the first thing we need to do is, well, we've already kind of talked about it, that this is a cube root function. The next thing we need to do is find H and K. If you notice, inside the stars it says minus H, but in here we have a plus 1. Well, what do you have to subtract to get a plus? It has to be a negative. So H is always the opposite of what it looks like. K, since it says plus K in our formula, it's always going to be exactly what's there. So it says minus 2, so K is negative 2. Now here's where the note cards that you made a couple class ago are going to come in handy. Find your cube root note card, and you need the chart off of that card, which said negative 8, negative 1, 0, 1, 8, negative 2, negative 1, 0, 1, and 2. That should be the chart that was on your note card. We're going to use that and the H and K that we found from our formula to get our new table. So X plus H times Y plus K. So we're going to add negative 1 to all our X's. And we're going to add negative 2 to all our Y's. Once we have our new chart, that's going to be what we graph. So negative 9 goes a little bit off our graph, negative 2, negative 4, negative 2, negative 3, negative 1, negative 2, 0, negative 1, and 7, 0. And then we're going to connect our dots so that it looks like a cube root and put arrows on the end. Once we have our picture, we can fill in our domain, range, and end behavior. Domain, because there's an arrow on the left and an arrow on the right, it's negative infinity to infinity. Range, at the left arrow is going down, the right arrow is going up. So we have negative infinity to infinity. As x goes to positive infinity, that's the arrow going up. So positive infinity. And then as x goes to negative, that's our arrow that's going down, so negative infinity. So let's look at another example. First, what type of function is this? Which one has the lines like this? That was our absolute value function. So we're going to copy down our absolute value chart from our note card. All right, based on this equation, h would be 2 and k would be 3. So we're going to make our new xy chart. So we're going to add 2 to all the x's. So we'd get 0, 1, 2, 3, 4. And add 3 to all the y's. So 5, 4, 3, 4, 5. Now we're going to graph our new xy chart. So 0, 5, 1, 4, 2, 3, 3, 4, and 4, 5. Since there's an arrow on the left and an arrow on the right, our domain is negative infinity to infinity. The bottom of our graph is at 3, so our range goes from 3 to infinity. And since both our arrows are pointing up, both our end behaviors are going towards positive infinity. Our third example uses a square root function. On our chart from our note cards, 0, 1, 4, 9, 0, 1, 2, 3. Now, h and k can be a little bit trickier with this one. Since the square root stops right here after the x, it stops there. There is nothing being added or subtracted to the x, so therefore h is 0. And then since the minus 1 is not under the square root, that tells us that's our k value. We're going to make our new xy chart. Adding 0 to all the x's won't change them. And adding negative 1 to all the y's will give us negative 1, 0, 1, and 2. So let's graph them. 0, negative 1, 1, 0, 4, 1, and 9, 2. Remember, this one only gets one arrow. So our domain, we still start at 0 and go to the right, so 0 to infinity. But our starting point got dropped down 1, so our range goes from negative 1 to infinity. Oops, and this shouldn't be there. My bad. And our arrow on the right is pointing up. And our last example, what if we're given the picture and we want to write the equation? So the first thing we need to recognize is what shape this is. This is a cube root function. And to find h and k, we need to find the center of it, which in this case is right here. It's going to be where it changes directions. In our absolute value or a quadratic, it'll be the vertex point, the one in the center. And if it was a square root function, you'd be looking for this endpoint here, the endpoint without the arrow. Wherever that dot is your h and your k value. So this is at the coordinate 2, negative 1. So that tells me that h is 2 and k is negative 1. Since it's a cube root function, I know y equals, and I'm going to have a cube root of x. Remember, h is the opposite of what it looks like, so it'll be minus 2. And then outside the cube root, after it's ended, we'll put k, so minus 1 goes on the end. That's all for today. Fill in your summary.